Alright, so I chose to do the clean and dirty shoe lab. I'm not the greatest of speakers, so bear with me on this one. Alright, so the whole idea of the lab is that basketball players, they constantly try to clean their shoes out on the basketball court. And the question is, how does this change the frictional characteristics of the shoes? So basically, and pretty simply, we're going to take a shoe with a dirty sole on an unclean surface, as you see, and then we're going to test the pull force, and then we're going to clean the surface and clean the shoe and then dry it off, and then test the pull force again, just like so. Alright, this is a dirty shoe on an unclean surface. Pulls across pretty simply. Didn't take that much of an effort there. And now we're going to take a wet rag and we're going to clean the bottom of the dirty shoe. Get all the dust and stuff off. And same goes on the surface that it was pulled on. We take a dry rag, make sure there's no extra water that could hinder the friction. Dry it off. And set it on there again. Hook it on there. And if you're watching the scale, you can see that it took just a little bit more force than it did as a dirty shoe. Alright, and the supplies I use obviously were shoes, scale, the weights for extra trials to prove our points here that you would put in, or the masses, I'm sorry, that you would put in there, and it would 100 grams would add it up to an extra Newton, and a flat surface and a wet rag to do the cleaning surface. Alright, so the mass of the shoe, also the weight, will be weighed in newtons, and it's also known as the normal force. Alright, the pull force, which is this right here, pulling the shoe across, the tension, would also be weighed in newtons, dirty and clean both. And the coefficient force, measured in mu, just a little u with a backwards tail on it, it's the pull force divided by the normal force, which would get you your data. Alright, and I made a little mock table here, which is what the table in the lab looked like. And I took one set of data here, so the normal force, or the mass of the shoe, would be 4.1 newtons. The pull force required for the dirty shoe, as you can see there, required 3.1 newtons of force. The clean shoe required 4.4, so substantial difference there. And then the coefficient force, which would be pull force divided by normal force for the dirty shoe, would be 0.9 mu, and the coefficient force for the clean would be 1.07 mu. And as you can see here on the graph, this is a graph from the different trials that we used with the extra masses. Each mass weighed 100 grams, which would add an extra Newton to the shoe. So it would make it 5.1, 6.1, etc. And as you can see here, the dirty shoe coefficient force compared to the normal force was almost a horizontal line. Not quite, but it did not hinder much of the pull force there. The clean shoe, however, was almost a vertical line. It was much more straight up than the dirty shoe and required much more force, especially as the weight was added onto it. And so the conclusion obviously is the clean shoe requires more pull force, or in our case, grip on the basketball court, which is a good thing, than a dirty shoe. So in hindsight, the basketball player probably wants a cleaner shoe to have better grip running up and down the court to play the game. Thank you.